Thank you, Nikhil, for that introduction. And it is awesome to be here, soaking up the energy, creativity, and innovation of a brand new form of transportation. And I find your vision for the future to be refreshing, invigorating even. And that's not easy to say coming from me, from where I sit, because we at the FAA have historically been a bit reticent to welcome new entrants in the national airspace system. But that is changing rapidly. It has to change, because this kind of energy, innovation, and vision is what will fuel the future of aerospace. And frankly, get the next generation of kids interested in taking part. Because they see innovation as a Tesla Roadster circling the sun, blasting David Bowie, or rocket boosters coming back and landing softly on the Earth. Or drones delivering popsicles, or slipping the surly bonds of traffic in a flying taxi. And look, let's face it, you guys make aerospace cool again. The energy you bring is also helping us at the FAA become more responsive to a rapidly evolving aerospace industry. Gone are the days when we could ignore an entrant that was radically different. Nowadays, we either evolve or we get left behind. And we learned that the hard way when UAS technologies and an entirely new industry sprung up practically overnight, and we weren't ready for it. Sorry. Well, we're sort of caught up now, but we're also determined not to let it happen again. And that's why we're out in front with Uber Air Mobility, or UAM, working with the industry and with NASA to make sure we get it right. Time is short. Companies are already testing a variety of vehicles, both in the US and abroad, and some already with passengers. And these two movements, UAS and UAM, really bring into focus how fast everything is changing now compared to earlier in my aviation career. You know, it doesn't seem possible that when I started flying C-141s as a pilot in the Air Force only 30 some odd years ago, and yes, I realize that 30 years is an eternity, and for some of the folks as I look out here, longer than they've been alive. But when I started flying, we had a dedicated navigator who would look through a small portal in the top of the flight deck with a sextant. Yes, a sextant. Sextant is essentially the same thing Magellan used hundreds of years ago to look at the stars to get a position fix on the high seas. Well, we got rid of the navigator and his medieval sextant in the 1980s when we ushered in the age of inertial navigation. And soon after, computers and advanced systems design made flight engineers obsolete, leaving us in the flight deck with a pilot and a co-pilot. The pace of change picked up in the late 90s with the introduction of GPS, which greatly simplified navigation. And when GPS was combined with sensor and actuator miniaturization, more computer power and lithium batteries, the unmanned aircraft revolution kicked into high gear. And then some very bright minds saw too many people sitting in traffic and thought, you know, we can take all this technology and create a better way to move around cities, UAM. And look what you in this industry collectively have conceived and are currently working on. These are truly some of the most exciting innovations and developments in aerospace since the Wright brothers. And it's all taken place over the course of really a very few short years. Everyone is riveted by this, especially me. But then I put on my FAA regulator hat, and I got a whole new bucket of stuff to lose sleep over. You see, what you see as the ideal way to transporting people across cities, when I look at it, I see car-sized vehicles with multiple rotors hanging over dense urban populations. And that's the challenge, taking an industry of incredibly bright minds and fast-moving technology and joining that with a regulatory agency that wants innovation, but only if it can be safely brought into an urban environment. It's why we have come up with the crawl, walk, run analogy. As I said earlier, the FAA can no longer just say no to a new entrant. We are evolving, and quite rapidly for us, into a more responsive regulator, I hope. And just like with technology, the pace of our evolution is accelerating. And back in the 80s, when I was first in the business, it was not unusual for the FAA to take 5 or 6 years to write a rule. Some are saying, well, that hasn't changed. Do you have the patience for that? And it's also normal or fine to take 10 or 12 years to develop and certify a new aircraft type, clean sheet. Do you have the patience for that? As you know, today with the tech eruption that is coming to the aviation world, product cycles can be measured in months. And we don't have the luxury of so much time anymore, but we have to ensure that safety is paramount. That cannot change. So how do we do that? We become a data-driven oversight organization that prioritizes safety above all else. To do safety right, you have to start with a safety culture. A good safety culture produces the data you need to figure out what's really happening. If we know about errors, we can fix the processes that lead to those errors. A safety culture demands that we infuse that safety data into all of our processes, top to bottom, in a continuous loop. When you think about how far aviation has come in a little more than a century, it's hard to argue the point. We've come from barnstorming to a safety record that is the envy of all modes of transportation. We evolve in our rulemaking by transitioning from prescriptive to performance-based rules. A few years ago, industry helped us modernize Part 23 airworthiness. Those are standards for how we certify small aircraft. Performance-based rules will ultimately form the backbone for how UAM vehicles will be built. For new entrants, we started with our legacy regulatory framework, but have evolved to an operations-first approach, where we use existing rules where we can and derive new rules where we need. And as usual, safety is the primary concern. Integrating UAS into the national airspace system is a good example. Our process is simple. Get the data to assess our risks, and then create useful regulations, policies, and guidance where needed. As a point of reference for how fast this industry is moving, the FAA has been registering manned aircraft for 92 years. And after only 4 years of registering drones, we now have 4 times as many drones as we have in all the rest of legacy aircraft. The UAS integration program, through a variety of demonstrations, is helping us capture data. It's also paying dividends on the investment side. Recently, the FAA granted the first air carrier certification to Wing Aviation, a commercial drone operator. Wing is doing beyond visual line of sight package deliveries in rural Blacksburg, Virginia, using existing rules. What happens next is that we gradually implement new rules to expand when and how those operators can conduct their business safely and securely. Now, we've just closed the public comment period for proposed new rules that would allow small UAS to operate over people and at night. On the horizon are the rules for beyond visual line of sight operations, which, as we all know, is the holy grail of UAS rules. So to manage the traffic, we're working with NASA and industry on a highly automated UAS traffic management, or UTM, system. And even though we're in the crawling phase of our crawl, walk, run path to full integration, we're seeing positive impacts. Small drones are already changing the landscape of our community and economy and society. And here are a few examples. In San Diego, the Chula Vista Police Department and CAPE, a private UAS teleoperations company, are using drones as first responders to provide aerial views for officers to document accident or crime scenes and search for missing persons. Since October, they have launched drone first responders on more than 500 calls, in which 67 arrests were made. And for half of those calls, the drone was first on the scene, with an average on-scene response rate of 96 seconds. Equally important is that 75 times out of that, a surface policeman wasn't needed at all. Just think about the safety ramifications of that. In Kansas, the State Department of Transportation showed us how to use drones for power line inspections and precise agriculture. And the Choctaw Nation of Oklahoma is using drones to bait feral hog traps. Yes, that is a feral hog trap. In North Carolina, drones delivered blood samples to a lab for testing. Drones delivered automated external defibrillators in Reno, Nevada, and inspected airport ramps and perimeter fencing in Memphis. Now, I have a strong hunch that the benefits we discover with urban air mobility will be no less extraordinary. NASA will again be our partner in this area with their UAM Grand Challenge that's planned for next year. The Grand Challenge is about bringing the best and brightest minds from government and industry together to begin live testing of carefully designed scenarios to show how a variety of vehicles and airspace management systems will or won't work together. And most importantly, bringing them together to gather data. That's crawling. We're not ready to walk or run yet. Walking and running will require that these highly automated or autonomous vehicles and systems meet the FAA's and the public's safety expectations for aviation. And as we've discussed, those expectations are very high. Now, the FAA, understand your desire to sprint out of the starting gate, but you have to understand our safety mandate. Let's begin this integration by working with industry to start crawling with low-risk operations in remote areas, gathering data, and evaluating safety all the while. When we're ready, we'll systematically graduate to high-density urban areas with semi-autonomous operations, which will be the walking phase. And eventually, the system will mature to fully autonomous operations in busy urban airspace, and we'll be running. And that's where, given the level of safety that we have in the National Airspace System, that's where we cannot fail. Achieving this final state for a radically different new entrant will be an evolutionary process, and it won't occur overnight, but it also won't take as long as it used to with yesterday's FAA. So here's my challenge to you today. Shoot for the stars. The commercial aviation safety record. In the past 10 years, there have been more than 90 million commercial flights in the NAS, carrying more than 7 billion people with one fatality. That's a safety record that's hard to get your mind around in any human endeavor, much less one where you're carrying humans in a highly advanced aerospace vehicles at 500 miles per hour, 7 miles above the earth. You are working to become part of an elite club, commercial aviation. Work hard. To be part of the safest mode of transportation on the planet, your operation must become synonymous with safety. That's the only way to fully exploit the energy and creativity of this exciting new innovation and this amazing new industry. So thank you all very much.